Imagine our planet, this beautiful blue marble, just hanging out in the vastness of space. It's our home, it's the only one we've got. Now imagine a threat, not from an asteroid or a solar flare, but from ourselves. Humans figured out how to split the atom, and with that, came immense power. And with that power came a terrible weapon, the nuclear missile. These aren't just big bombs, they're city destroyers, civilization enders. They travel at incredible speeds, thousands of miles per hour, arcing through the upper atmosphere and even into the vacuum of space, before coming back down. The sheer destructive force is hard to grasp, like bottling a piece of the sun and dropping it on a city. So, the question becomes, can we stop it? That's the question driving missile defense, a cosmic game of catch with unimaginable stakes. The goal, build a shield, a multi-layered system to protect us, not to start a fight, to end one before it truly begins. Think of it as a planetary immune system, detect, track, and intercept. A network of sensors, computers, and interceptors in concert. It must be fast, precise, and incredibly reliable. So, how do you stop a missile you can't see? First, you have to find it. This is the detection phase. The right eyes in the right places. By eyes we mean powerful sensors, on the ground, and way up in space. An ICBM's engines create a mini-sun of heat and light. Can't hide that energy signature. Geosynchronous satellites stare 24/7 for the telltale flash. Cosmic sentinels, celestial watchtowers. They carry ultra-sensitive infrared sensors. Infrared light we feel as heat. A launch glows blindingly bright in IR. Systems like SBIR's alert command within seconds. First precious warning. We know it launched and roughly where from. But that's just the beginning. After staging, ground radars take over. Colossal arrays, blasting radio waves. Think SBX and global early warning radars. Pulses hit objects and bounce back. Echolocation at scale. Time and direction yield position, speed, trajectory. Like bats in the dark, using radio, not sound, seeing hypersonic objects hundreds to thousands of miles away, discriminating warhead, boosters, debris, decoys. Decoys are designed to fool defenses. Satellite and radar data are fused for clarity, from flash to a clean track in the sky. Now, figure out exactly where it's going. An ICBM can cross the world in about 30 minutes, less time than ordering a pizza. Every second matters. Our sentinels spotted a launch. Radars track a screaming object. What now? The magic happens in the system's brain, some of the most powerful supercomputers on Earth, ingesting a flood of sensor data, making sense of it in minutes. Connect the dots, filter out the noise, predict the future. Millions may depend on these calculations. This is sensor fusion. Infrared gives when and where it launched. Radar provides precise position, velocity, and heading. A high-accuracy track file emerges. But attacks may include multiple warheads, MIRVs, and clouds of decoys and chaff. Complex algorithms discriminate real from fake. The system looks for subtle clues, how each object moves in near space. A heavy warhead follows a predictable arc. Light decoys drift more with drag. Temperature differences help discriminate. Computers run countless simulations, compared to known threat profiles, and physical models, celestial forensics. Once the real warhead is identified, calculate the intercept. Derive a precise fire control solution. Transmit instructions to the Guardians. Time to launch. We've detected it, we've tracked it, we've calculated its path. Now comes the interception. This is where we fight back. Destroy it high above the atmosphere, in the vacuum of space, so debris burns up on re-entry. You don't want it breaking over cities. We use interceptor missiles, defensive rockets to meet and destroy. Launch is just the first step. Guidance is the real challenge. Hit a small car-sized target, moving over $15,000 menopause, like a bullet hitting a bullet, both at hypersonic speeds. The interceptor is multi-stage boosters get it to space fast onto a collision course. Then it releases the EKV, the kill vehicle. The EKV does the actual hitting. It is not explosive kinetic energy obliterates the target. At those speeds, energy is enormous. EKV uses infrared sensors and tiny thrusters for fine guidance, a smart, self-guided space bullet. Final seconds, updates from ground and its own eyes, minute adjustments for a direct hit, locks on the hot warhead, ignores decoys, then a silent, violent collision catastrophe averted by precision. Missile defense often means massive rockets from silos hidden in the ground. This is ground-based defense built to stop limited numbers of ICBMs, fixed sites covering likely corridors, a 21st century fortress wall, engaging during the mid-course phase. Prime example, US GMD, shield against ICBMs from North Korea or Iran. Interceptors in silos at Fort Greely, Alaska and Vandenberg, California. Placement is strategic. Alaska covers polar approach vectors. Cosmic geometry meets national defense. GMD links interceptors to a global sensor web. SBIR as spots launches radars refine trajectories. Computers fuse data. Fire control sends a GBI roaring skyward. A 3-stage rocket carrying the EKV. Rocket delivers. EKV does the hit. A cosmic delivery with a crucial package. GMD is for small numbers of simple ICBMs, not a massive barrage from Russia or China. Hundreds of warheads and decoys would overwhelm it. But against a rogue or accidental launch, it's a critical last resort shield. Not on my watch. Lives protected by layers. Now, put the shield on the move. That's sea-based missile defense. Not fixed silos, but warships, destroyers and cruisers. Incredible flexibility. Sail to any ocean. Defend allies. Protect deployed forces. Create regional shields. A mobile shield where needed most. Mobility complicates enemy planning. Champion, Aegis ballistic missile defense. Heart of Aegis, SPY-1 radar. Scanning all directions at once, tracking hundreds of targets from low cruise missiles to high ballistic missiles. Aegis, named for Zeus's shield, a guardian for its crew. Vigilance at sea. Aegis fires SM-3 interceptors. Vertical launch cells hold dozens. SM-3 intercepts in mid-course, hit to kill in space. Covers Europe versus regional threats. And Japan and South Korea versus North Korea. Not just long-range SM-6 handles terminal shots, and THAAD can complement. Two-layer defense from one ship, dramatically boosting success odds. Guardians of the deep, vital and flexible. The ocean, shielded. We have defenses on the ground and on the sea. What's next? The ultimate high ground, space. Space defense has been a decades-long dream. Imagine satellites ready to strike during boost, when missiles are big, hot, and slower, easier than hitting tiny cold warheads in space. SDI, Star Wars. Envisioned this in the 1980s. Space lasers, particle beams, and brilliant pebbles swarms. Ambitious and controversial. Proponents saw nukes made obsolete. Critics saw technical, cost, and stability issues. A vision out of cosmic sci-fi. Today, focus shifted toward networks of space-based sensors for birth-to-death missile tracking. HBTSS aims for continuous high-fidelity tracks, making ground and sea intercepts easier. But space weapons remain contentious. Treaties ban WMDs in orbit and oppose militarizing space. Deploying interceptors in orbit is astronomically expensive and could trigger an arms race. For now, space is for detection and tracking. The all-seeing eyes for terrestrial shields. High ground, wisely used. Vision tempered by reality. Watching, not shooting. Progress without provocation. It sounds great in theory. We have sensors, computers, and interceptors. But does it actually work? A qualified yes, with caveats. Track record, mixed but improving. Rigorous live fire tests. Launch a target, then try to kill it. Scenarios grow more realistic. Let's check the report cards. GMD success rate, more 50-60% in tests. 11 hits out of 20 since 1999. Critics say 55% is low, and tests are scripted. Known time and origin, simpler than real-world decoys. But recent tests trend upward. Even dual shoot to raise kill probability. Shorter range systems fare better. Aegis BMD. Excellent record. 40+ successes in 50+ attempts. THAAD. Perfect in 15+ tests. Credible deterrent, real protection. Major limitation, scale. Large, sophisticated barrages overwhelm. New challenge, hypersonic gliders. Mach 5+ and maneuverable. Hard to track, harder to hit. The sword and shield race never ends. We adapt, iterate, improve. Realistic, not invincible. So, where does that leave us? Nuclear annihilation risk persists. Diminished, not gone. More long-range missiles. New, faster weapons, a dangerous world. Missile defense is no panacea, not an impenetrable astrodome. Beware oversimplification. It's one tool in a larger strategy. A cosmic insurance policy. You hope never to use it, but you pay anyway. Fires, cars, floods, now scale that to a planet. An investment in survival. Value isn't only in shooting, it changes an aggressor's calculus. Credible defense deters. It introduces uncertainty, stability through doubt. Development continues, from atom splitting to shield building. Scientists, engineers, improve our sensors, write smarter algorithms, build faster, more agile interceptors. Hypersonics drive innovation. We must see and react faster. Beyond tech, people, and peace. We refuse to live under the nuclear shadow. With diplomacy and a shield, we safeguard our only home.